Okay, so now we're going to look at number 26, PbClO3,4 plus CaCrO4. Alright, so what I'll do is I will draw these out, and just so we can figure out exactly what we're going to take over to the other side here. And we've got 4 ClO3s here, and we've got Ca and CrO4. And this is a polyatomic ion you can find on the polyatomic ion sheet, and there's just one CrO4 group here. What we're going to do is we're just going to work with these. We can take one of each of these over the other side, realizing of course the Pb will join with the CrO4 and the Ca will join with the ClO3. But again, just one of each, so Pb with the CrO4 and the Ca with the ClO3. Looking at the charges, we've got negatives on each of these because that's what the charge is on the polyatomic ion sheet. So that'll be a total of -4 on the negative side there. We've got +4 for that one. That means lead's going to be 4 plus. Over here, if we look at the polyatomic ion sheet, we see that's got a 2 negative charge, chromate, and that means that's going to have a 2 positive charge. So we're okay there. So transferring those charges, we've got Pb4 plus, 2 minus, CrO4, 2 plus on the Ca and negative on the ClO3. Alright, so remember just one of each over to the other side there. Even though there's 4 ClO3s here, we're not going to worry about that until we balance it out at the end. Alright, so now we can go ahead and see how these plonk together. This is for part A. So we can see, we'll just write this out again. PbClO3 4, CaCrO4. Now I'm looking at this and I see I've got Pb4 plus and CrO4 2 minus. And what I'm saying to myself is, how many of each of these do I need to make this balance out? And it'll be Pb and then 2 CrO4s, because that's 4 plus and that's 2 negative. I have 2 of those, that's going to be -4, and that will balance out. Then I've got Ca, and I need 2 ClO3s to balance that one out. If I look at the solubility chart, I'm going to find out that lead chromate is the solid. And now I can go ahead and balance this up, and I'm going to have 1 lead. I've got 4 ClO3s, so I'm going to need to put 2 in front of here to balance that out. So that's going to be 2 Cas. I put 2 in front of here. That gives me 2 chromates and 2 chromates. So everything balances out now, and that would be it for number A. Now for B, what I'm going to do is show how this splits into ions. So we've got 1 lead and 4 ClO3s, and we can just get the charges from up here. We already had them earlier, same way. So that's going to be 1 Pb4 plus. We've got 4 ClO3 negatives there. And now I've got CaCrO4, so I've got 2 of those. That's 2 plus, that's 2 negative. The PbCrO4 2 does not split into ions because it's a solid. And this one's going to go CaClO3, ClO3, and we've got 2 ClO3s. And the charges here, 2 plus, and negative, 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 and negative. Alright, so now we can go ahead and figure out how many of each we've got. So we've got 1 Pb4 plus. I've got 1, 2, 3, 4 ClO3 minuses. I've got 2 Ca2 pluses. I've got 2 chromates. And we've got PbCrO4 2, and then we've got 2 Ca2 pluses plus 4 ClO3 minuses. And that's how this would look. Remember, I haven't shown the aqueuses on these, but all of these are aqueous, and this one here is going to be the solid. Alright, so that's what that looks like for part B. So that's the the full Ionic equation. Now what I'm going to do is show the net Ionic equation here, and again I will copy this. And I'll bring it down here, and this will be for part C. I'm going to go ahead and erase this part of it, bring this back up. There we go. Alright, so this will be for part C. And part C here I've got PB4 plus, and I'm going to cancel out anything that's exactly the same on each side. PB4 plus is okay. That cancels with that, and the Ca2 plus is cancel, and we're just left with whatever forms a solid. So it'll be PB4 plus 2 CrO4 minuses, 2 minus, and then that'll give us PB CrO4 2 and solid. So that would be the net Ionic equation right there for number 26.